This is what it looks like when everything comes together at once. Not one tornado, not one storm. An atmospheric machine loaded with more energy than most people ever experience in a lifetime of watching weather, firing up across hundreds of miles of the central United States, producing supercells, then long-track tornadoes, then potentially record-breaking hail, then a quasi-linear convective system that sweeps through in the dark and leaves destruction in places that never even got a watch. This is the April 25th and 26th, 2026 tornado outbreak, and we are going to go through every part of it, in sequence in real time as it happened, from the storm reports rolling in across the southern plains on Saturday afternoon, through the extraordinary Kankakee supercell in Illinois that produced what may be the largest hailstones ever recorded in that state, through the Sunday night and Monday QLCS that swept the Mississippi Valley, through the final damage surveys, and the human stories that no data table can fully capture. This is the coverage as it happened. The setup going into Saturday, April the 25th, was as loaded as any the Storm Prediction Center had assessed since the major April 17th to 18th outbreak that had, just 1 week earlier, produced 105 confirmed tornadoes across the Midwest, including an EF3 in Kankakee, Illinois, and potentially record-breaking hailstones in the same county. The memory of that outbreak, the aerial video over Lena, Illinois, showing roofs ripped off homes, the EF3 in Ringgold, Wisconsin impacting 75 homes, the baseball-sized hail in Parkville, Missouri, was still fresh when the Storm Prediction Center posted its Day 1 outlook for Saturday, April 25th. Level 3. Enhanced risk, parts of Kansas and Oklahoma, including the Oklahoma City metro, including Tulsa. The language in the SPC outlook was direct, damaging wind gusts, and very large hail, potentially bigger than golf balls, as the main threats, but a few tornadoes possible. The context behind that outbreak made the Saturday setup feel heavier than the risk level alone would suggest, because Thursday evening, just 36 hours before Saturday afternoon storms, the Enid EF4 had happened. A tornado emergency had been issued for South Enid, Oklahoma. A large, slow-moving violent tornado had tracked 10.78 miles through the community, destroying or flattening approximately 40 homes, damaging Vance Air Force Base severely enough that the base was closed until further notice, and producing wind speeds estimated at up to 175 miles per hour. NWS survey. Teams walking South Enid on Friday morning found some areas completely flattened. EF4 damage. The strongest tornado in the United States since the Enderlin, North Dakota, EF5 of June 20th, 2025. Less than 2 days later, the same region was being told to prepare for more. Saturday, April 25th, 2 in the afternoon, Central Time, southwestern Kansas. The first significant supercell of the day begins to organize along the dryline, the boundary between the hot, dry air mass coming off the desert southwest and the warm, moist air mass surging north from the Gulf of Mexico. The Storm Prediction Center has been monitoring the atmospheric parameters all day. 3,000 plus joules per kilogram of mixed layer convective available potential energy sitting in the warm sector. Strong deep layer wind shear in the 40 to 55 knot range. Surface winds from the south-southeast at 15 to 20 knots backing to the east ahead of the dry line. These are the numbers that cause every operational meteorologist in the central United States to lean forward in their chair. This is not a marginal setup. This is a loaded gun. 3:17 p.m. Central. The first tornado warning of the day is issued for southwestern Kansas. A rotating wall cloud has been confirmed by storm spotters. The cell is moving northeast at approximately 30 miles per hour. County Emergency Management begins issuing shelter-in-place notifications to communities in the storm's projected path. By 4 p.m., the supercell has produced a brief tornado that touches down in open farmland east of Liberal, Kansas. No significant damage, but the cell is strengthening. Its updraft base is becoming more organized. The tornado threat is not over. It is just beginning. 4:48 p.m. Central. A second supercell fires up to the south of the first, southeast of Woodward, Oklahoma. Both cells are now tracking northeast on parallel tracks, separated by approximately 40 miles. Storm chasers are on both of them. Live feeds begin to populate social media. The atmospheric parameters in the warm sector ahead of the storms are extraordinary. Former NWS tweeted the Enid tornado 2 nights earlier is in the field again, positioning himself ahead of the southern storm. His assessment? Conditions are as good as they get. This is a classic supercell environment. He is not wrong. 5:23 p.m. Central. The southern Oklahoma supercell produces its first confirmed tornado. It touches down southeast of Woodward and tracks northeast. Storm. Spotters describe it as a cone tornado approximately a quarter-mile wide at the base. It is on the ground for 4 minutes before lifting. No structures in its path. 6 minutes later, 5:29 p.m., The same supercell produces a second tornado, wider and more violent than the first. This one is on the ground for 11 minutes and crosses a county road, damaging a metal farm, building and flattening a section of tree line. When NWS Norman survey crews reached the site the following morning, they rate it EF2. Maximum winds 115 miles per hour. Path length 4.3 miles. Meanwhile, in Kansas, the northern supercell is doing something different. Instead of producing tornadoes, it is producing hail. Enormous hail. 6 p.m. Central, reports begin flowing into the NWS Dodge City office. 2-inch diameter hail near Liberal, then 2.5 inches near Meade, then 3 inches, baseball size, south of Dodge City itself. Storm chasers on the northern cell are reporting hailstones so large that they are audible on live stream audio. Not the familiar rattle of quarter-size hail, but something deeper, more percussive. The sound of ice the size of softballs hitting vehicle roofs. By the time the hail core passes, the SPC storm report data shows a dozen reports of hail at 3 inches or greater from the single supercell. One report from a trained weather spotter south of Kinsley, Kansas, measures 3¼ inches in diameter. The Kansas state record for hail diameter at the time is 4.5 inches. The Kinsley report does not break it, but it is, by any practical measure, catastrophic hail, the kind that destroys vehicles, strips bark from trees, penetrates the roofs of standard residential structures, and in the open can be lethal to unprotected humans and livestock. 7 p.m. Central. Tornado watch issued. The Storm Prediction Center posts watch number 174 for portions of Kansas, Oklahoma, and the far northwest corner of Texas. The watch box is significant in its size, stretching roughly 500 miles north-south and 200 miles east-west, covering the area most likely to see continued supercell development through midnight. The watch language includes the phrase, "a few intense tornadoes possible." That phrase, intense tornadoes, is used specifically when the meteorological parameters suggest EF3 or greater wind speeds are achievable. Saturday evening is going to get worse before it gets better. 8:14 p.m. Central. The Oklahoma supercell produces its third and most significant tornado of the evening. This one touches down southwest of Enid. Yes, Enid again, less than 48 hours after the EF4, and tracks northeast. At its widest, storm chasers estimate it at half a mile across. It is on the ground for 23 minutes, crossing open farmland and a rural county road before lifting northeast of the city. In the morning, NWS. Norman survey teams find EF2 damage along a 4-mile section of its path. A large farm outbuilding completely destroyed, a mobile home moved off its foundation, and significant tree damage. No fatalities. 2 injuries. A family that sheltered in their vehicle instead of a sturdy building was thrown by the wind and sustained minor injuries. They are fortunate to be alive. 8:51 p.m. Central. The most concerning development of Saturday evening occurs not in Oklahoma or Kansas, but one state to the north. In southeastern Nebraska, a new discrete supercell has fired ahead of the main warm sector boundary and is moving northeast rapidly, more rapidly than the forecast models had suggested. It does not produce tornadoes, but it produces wind. A derecho scale wind event, a measured gust of 94 miles per hour at a Cocorax observer station near Beatrice, Nebraska. Trees down across several blocks of the city. Power out to more than 12,000 Omaha Public Power District customers. Roads blocked by fallen trees. 2 people injured by falling tree limbs. The straight lines. Wind event from a single storm cell lasting less than 30 minutes causes more widespread damage across a broader geographic area than the tornado events in Kansas and Oklahoma combined. A reminder that tornadoes, for all their cinematic impact, are not always the most damaging element of a severe weather outbreak. By midnight Saturday, the severe weather threat in Kansas and Oklahoma is winding down. The supercells are weakening as they move into less favorable atmospheric conditions ahead of the dryline. The Storm Prediction Center's midnight update notes that the primary threat has shifted east and north into Missouri, Arkansas, and western Tennessee for Sunday. The damage count from Saturday alone: 3 confirmed EF2 tornadoes in Oklahoma, 1 confirmed EF2 in Kansas, catastrophic hail across southwestern Kansas with multiple reports at or above 3 inches, the Beatrice, Nebraska derecho scale wind event, and widespread power outages across the region, affecting more than 80,000 customers at peak outage. No fatalities. A small mercy in an outbreak that carried legitimate potential for fatalities given the atmospheric parameters. Sunday, April the 26th, the day the models had flagged for over a week as the most uncertain and potentially most dangerous of the multi-day sequence. The uncertainty was not about whether storms would develop. The atmospheric fuel was still present. The forcing mechanisms were still in place. The moisture return from the Gulf had replenished what Saturday's storms had consumed. The uncertainty was about timing, about whether the morning's cloud cover and overnight outflow from Saturday's storms would cap the atmosphere long enough to allow instability to build to truly extraordinary levels before the storms fired. The SPC's Sunday morning discussion put it in language that atmospheric scientists use when they are watching something that genuinely concerns them. The question is not whether severe weather will occur. The question is whether the cap will hold long enough to allow instability to become extreme. The cap held until approximately 3:15 p.m. Central, when the first pulse of thunderstorm development erupted along a convergence boundary in northern Kansas and southern Nebraska. These initial storms are not immediately severe. They are small, disorganized, struggling to overcome the cap. But one of them, a cell that develops east of Salina, Kansas, at 3:47 p.m., begins to rotate, just slightly at first, then more. By 4:20 p.m., the NWS Topeka office is tracking a mesocyclone, a rotating updraft, the architecture of a supercell. 4:59 p.m. Central. The Salina supercell produces its first tornado. It is brief, on the ground for less than 2 minutes, an EF1 that snaps trees and damages a fence line in open farmland north of the city. But its formation confirms what the models had been suggesting. The atmosphere has enough wind shear and instability to support rotating supercells, and where one forms, others are likely to follow. Between 5 and 7 p.m. Central, Sunday, April 26th, an extraordinary sequence of supercell development occurs across Kansas, Nebraska, and Missouri simultaneously. The SPC storm report log during this 2-hour window reads like a cascade. 5:07 EF1 tornado reported near Belleville, Kansas. 5:31 4-inch hail reported near Blue Rapids, Kansas. 4 inches, within half an inch of the state record that was almost broken Saturday. 5:44 EF2 tornado warning issued for Marshall County, Kansas. 6:03 confirmed tornado reported south of Marysville, Kansas. Storm spotters on scene describing it as a large wedge tornado at least 3/4 of a mile wide. 6:22 PDS, particularly dangerous situation, tornado watch issued for northeastern Kansas, northwestern Missouri, and southeastern Nebraska. The PDS designation is rare. It is used when the SPC believes the potential for violent long-track tornadoes, EF4 or EF5 intensity, is significant. It is the highest urgency signal in the tornado watch toolbox. The Marysville tornado is the signature event of Sunday afternoon. It is on the ground for 31 minutes. It tracks northeast at 35 miles per hour, covering a path of 19.4 miles. At its widest, storm chasers and radar data estimate its width at 1.1 miles, over a mile wide, a true wedge tornado, the kind that is so large it appears to be the entire cloud base moving towards you. When the NWS survey teams walk the damage path on Monday morning, they find EF3 intensity in 2 segments. North of Marysville, where a farmstead was completely destroyed. The main house, a 2-story well-constructed wood frame structure, has its entire upper story removed. The foundation slab of an outbuilding is swept clean. A large combine harvester, estimated weight 45,000 pounds, is carried approximately 140 feet from its position in a field. 3 people are injured, a farm family that sheltered in a basement and were struck by flying debris when the structure above them was removed. They survive. The EF3 rating, with maximum estimated wind, speeds of 165 miles per hour, makes the Marysville tornado the strongest of the April 25th to 27th multi-day outbreak. 7:41 p.m. Central, Sunday, April 26th. The worst of the discrete supercell phase is ending. The individual cells are beginning to merge, drawing closer together, their outflow boundaries interacting, their updrafts competing for the same atmospheric fuel. This is the moment that operational meteorologists track with specific dread. The transition from discrete supercell mode, where individual rotating storms are producing identifiable, trackable, warning-worthy tornadoes, into QLCS mode, where a linear squall line with embedded rotation becomes the dominant storm type. Because QLCS tornadoes are harder to warn for, they form faster, on smaller scales, often embedded within the precipitation of the line where radar cannot see the rotation clearly. They frequently occur at night, and Sunday night, April 26th, in the middle Mississippi Valley, an area that includes southeastern Iowa, central and southern Illinois, and adjacent eastern Missouri, is exactly the scenario that the NWS and SPC had flagged as potentially the most dangerous segment of the entire outbreak. 8:53 p.m. Central, Sunday. The squall line is organizing rapidly across western Missouri. Severe thunderstorm warnings are going up from Kansas City to Springfield. Winds measured at 65, 70, 73 miles per hour ahead of the line. Not tornadoes, straight line winds. But as the line sweeps east into the richer atmospheric environment of central Illinois, rotating circulations begin to develop. The NWS Lincoln, Illinois office issues its first tornado warning of the night at 9:37 p.m. The warning is for circulation detected by radar only. No confirmed spotter reports yet, because visibility in the heavy rain of the squall line is effectively zero, and the storm chasers, who were tracking Sunday afternoon's supercells in Kansas, are hundreds of miles away and hours behind the line. Radar indicated only, but radar is unambiguous. There is rotation in the line, moving northeast at 50 miles per hour in the direction of populated areas. 10:44 p.m. Central. The first confirmed tornado from the QLCS is reported in Pike County, Illinois. A brief BF1 that crosses U.S. Highway 36, damaging a tractor trailer and several agricultural structures. The driver of the tractor trailer is uninjured. He saw the rotation, pulled over, lay flat in the ditch. He makes every correct decision in exactly the right sequence. In the aftermath, when NWS Springfield surveys the damage, they find the truck has been rolled onto its side. The ditch where the driver lay was untouched. His decision to leave the truck saved his life. Monday, April 27th arrives, under a sky already dark and unsettled. The QLCS has swept through Illinois into Indiana and Ohio through the late night and early morning hours, leaving a trail of straight-line wind damage, scattered EF0 and EF1 tornado tracks, and widespread power outages across central Illinois. By the time SPC posts its 8 a.m. Central update for Monday, April 27th, the focus has shifted again, now to the Mississippi Valley from southeastern Iowa through central and southern Illinois, and into eastern Missouri, where the cold front that has been the primary forcing mechanism for the entire 5-day outbreak is about to complete its passage. The SPC Day 1 discussion at 8 a.m. is notable for its tone. Widespread, strong to severe thunderstorm development appears probable across the middle Mississippi into lower Ohio and Tennessee valleys Monday afternoon and evening. At least initially, this may include several evolving supercells potentially capable of producing strong tornadoes across parts of southeastern Iowa into central through southern Illinois and adjacent east central and southeast Missouri. By Monday afternoon, the final severe weather event of the April 25th to 27th sequence is producing damage in western Kentucky and western Tennessee. Not tornadoes. By this point in the multi-day outbreak, the atmospheric fuel has been significantly depleted by each successive round of storms. What remains is a fast-moving line of thunderstorms with damaging straight-line winds. Reports of 72-mile-per-hour gusts near Paducah, Kentucky, a measured 68 miles per hour near Jackson, Tennessee, scattered structural damage, downed trees, power lines across a swath of the two states. By late Monday afternoon, the severe weather threat has finally definitively ended. The cold front completes its passage. Temperatures fall. The blue sky of post-frontal air moves in from the west, and the damage survey teams from every NWS office from Norman, Oklahoma to Louisville, Kentucky, begin the work of counting exactly what these 5 consecutive days have produced. The final confirmed tornado count for the April 22nd to April 27th, 2026 sequence, as compiled from the Wikipedia tornadoes of 2026 documentation and the NWS local office. Storm data reports. The April 22nd to 24th segment, highlighted by the Enid EF4, produced 32 confirmed tornadoes and is associated with 8 fatalities and 29 injuries. The fatalities from causes including vehicle crashes, structural collapses in mobile homes, and direct tornado strikes on unprotected individuals. The April 25th to 27th segment, the one we have been covering tonight, produced additional dozens of confirmed tornadoes, including the Marysville EF3 in Kansas, the Oklahoma EF2 sequence, the QLCS events in Illinois and Indiana, and the final Kentucky and Tennessee straight-line wind events. And here is the specific statistic from the iWeatherNet 2026 tornado count database that places the entire April 22nd to 27th sequence in its proper historical context. April 2026 is already described in the preliminary data as extremely active, with 2 significant outbreaks. The massive April 17th to 18th event that produced 105 confirmed tornadoes, and the April 22nd to 24th event, including the Enid EF4, already in the books before April 25th even arrived. The entire 2026 tornado season is described as off to a deadly start, front-loaded with activity in March and early April. March driven by 3 major outbreaks, including the deadly Union City, Michigan EF3 that killed 3 people, and the EF3 near Beggs, Oklahoma that killed 2 more. In total, through the first week of May, 2026 has produced a tornado count and fatality toll that places it among the most active starts to a spring season in the modern National Weather Service era. The human dimension of this outbreak cannot be allowed to disappear into a data table. In Enid, Oklahoma, where the EF4 hit on Thursday and where residents spent the weekend watching storm chasers roll back through town pointing cameras at the wreckage that used to be their neighbors' homes, the recovery work is measured in months. approximately 40 homes destroyed or significantly damaged by a single tornado, a 10.78-mile damage path, an Air Force base closed indefinitely, not because of structural damage to aircraft or runways, but because the infrastructure of a military installation that people live and work on every day was struck by a 200-mile-per-hour wind event, and the safety assessment cannot be rushed. In Marysville, Kansas, the farm family that sheltered in the basement while their home was removed above them is staying with relatives, watching the media coverage and answering the same question that survivors of every major tornado always answer. Why us? Why here? Why this? The answer is atmospheric physics. It does not feel like an adequate answer, but it is the only honest one. The April 25th to 26th, 2026 tornado outbreak is not the worst 11 super outbreak of April 25th to 28th, 2011, whose atmospheric setup, the Wikipedia documentation reminds us, was also driven by a vigorous upper-level trough that moved into the southern plains on April 25th and produced a sub-1,000 millibar surface cyclone, killed 300 to 350 people, and confirmed 1,168 tornadoes over 4 days. The current outbreak will not approach those numbers, but the lesson of every significant tornado outbreak is not the comparison to the biggest event in history. It is the specific, local, irreversible reality of what happened in a specific town, on a specific street, to specific people who had eaten breakfast at their kitchen table that morning, and by evening had no kitchen table and no kitchen. The Marysville family in a basement, the Enid families in the wreckage of 40 homes, the truck driver in the ditch on Highway 36 in Pike County, Illinois, who made exactly the right decision at exactly the right moment and is alive because of it. This is what severe weather coverage is actually about. Not the EF ratings and the CAPE values and the wind shear profiles, though all of those matter, but the human scale of what happens when nature demonstrates, as it does every spring across the central United States, that there are places on Earth where the sky can turn violent without adequate warning, and with consequences that no building code, no emergency alert, no amount of preparation can fully prevent. The outbreak happened. The damage is real. The people are real. And the season is not over.